EUI-64 Explained simply in this video. Now, we've been talking about IPv6 in our series previous to this video, and we've been talking about the protocols that are used in IPv6 compared to IPv4 or the IPv4 addressing system. Now we're going to get into IPv6 EUI-64 Explained so that you understand why that protocol is needed in the IPv6 system. So stay tuned. So in all of these other videos, I've been showing you how IPv6 works, and I've also shown you most of the protocols used in IPv6, which ones are still used from the classic IPv4 system, and which protocols are new only to IPv6. If you recall, and you've probably encountered this on a desktop or a laptop somewhere, and probably recently, when a computer boots up on a network and requests an IP address, it will do what's called self-assignment of an IP address just to finish out the boot up process and loading of its operating system. That's a mouthful, so let me clarify. You boot up a computer running Windows that's connected to a network. It may detect that it's connected to a network via network cable, but on a Windows system, you'll show an IP address on your desktop or laptop that starts with 169.something.something.something. And you won't have connection to the actual network. This indicates Windows did what some call self-assigning itself an IP address. In the IPv6 world, you have a very similar function or protocol called EUI-64, and this stands for Extended Unique Identifier, 64-bit. And I'm going to clarify what this means. If you've watched some of my previous videos on IPv6 in this series on IPv6, you'll recall I mentioned what's known as a link local address. When a computer running IPv6 boots up, it gives itself an IPv6 address. Now, the first 64 bits of a link local IPv6 address are always FE80. We'll represent it here. It's followed by 54 0 bits. So when you see the FE80 at the beginning of an IPv6 address, you know that it's a link local address. So every link local address begins with FE80 :4 zeros :4 zeros :4 zeros, and you kind of get the gist of that. The second half of a link local IPv6 address, in other words, the other 64 bits of that address, are called the unique identifier. And the unique identifier is created in two different ways. Beginning with Windows Vista, released years ago, all Windows clients will generate a random 64-bit number for the unique identifier, the second half of the link local IPv6 address. Other operating systems like Linux, as well as Windows Server 2008 and beyond, also use randomized numbers, 64-bit numbers, for the unique identifier portion of the IPv6 address. However, older operating systems like Windows XP, Windows Server 2003, and a good number of Cisco router interfaces will actually look at the MAC address on the computer or the interface to create that last unique identifier, that 64-bit number. And when they do this, this is known as the EUI-64, or the Extended Unique Identifier. So as we get close to wrapping up our little series explaining IPv6 and talking about the IPv6 protocols here, you'll need to know this one, the EUI-64, as well for the exam certification and for your career or your business going forward in the computer networking field. The IPv6 EUI-64 explained like this should really help you and make it simple and easy for you to remember and understand. Be sure to look for my upcoming videos on IPv6 tunnels and how they work, because that's going to kind of wrap up our series on IPv6. And make sure to subscribe to my channel and click the bell notification if you'd like to be notified when I release new videos on this channel. Also, be sure to comment below if you've already seen or had to deal with IPv6 yourself out there in the real world. And I will see you on the next video.